Before we get into the nitty-gritty, what actual concrete tools you should learn to become a great engineer, we first need to talk about the fundamentals. Your role and mission as a software engineer is to get good at building puzzle pieces that build on top of each other and fit together. Fundamentally, this means you need to figure out a loop of learning things, trying things, iterating, getting feedback, and improving. This means to avoid a common pitfall, a common trap that many people go into, which is to watch YouTube tutorials on how to build, for example, a React Native e-commerce app or something like that. You will only get something from these videos if you already are doing the work yourself and you just, at the end of the day, to relax a little bit, watch those videos to get an idea what other people are doing. But if you rely on them as your primary engine to learn, you will fall into this trap. Another trap that people point out is not actually a trap, but a strength. This is using resources like Stack Overflow and blindly copy-pasting the code without understanding it. You have a lot of sensory overload when you have to learn all these things, and so you will naturally have a lot of blind spots. You will not have the time to learn all about filling the blind spots. Instead, you have to figure out how to get your code working. First, make it work, then make it right. This means there will be blind spots in the Stack Overflow answer, and it's fine to ignore them and circle back later to then learn them. Talking about Stack Overflow also is a good transition because your core skill is to research stuff. This means Googling things and scanning the results for useful stuff. Basically, you have to build a mental model, a theory of how stuff works on a higher and lower level. And there will be many blind spots in this theory, in this mental model. And you need to navigate through it and appropriately fill those blind spots by researching. Google will be your best friends, and commonly you will find Medium articles which are mediocre, and the most valuable thing you will find is Stack Overflow answers. These are a fantastic great resource and a mainstay. However, don't be tempted to ask questions, that's usually a poor experience, but get good at scanning those questions and results on Google. One tool I recently added to my toolbox is to use ChatGPT more. It's very tricky to use ChatGPT because it will hallucinate and will be terribly outdated in the fast-moving world of software engineering. However, it often can fill the gap and is a great pointer on roughly how to approach problems and get started on stuff. I wouldn't rely on it too much, but oftentimes there are gaps or lackluster documentations in tools you want to use, and ChatGPT can help you integrate them into other tools, give you the rough idea on how to do that at least, and generally speaking provide you maybe with some boilerplate code that serves as a pointer to then research and go to the actual places, the documentation, where you find the source of truth for this. Spoken enough about the fundamentals, let's talk about concrete things to start with. I highly recommend learning JavaScript, even though it is a highly hated language. But as they say, there's those programming languages that are hated by everyone, and then there's those nobody uses. JavaScript is super versatile, you have a lot of creativity, and this is also what you should do. You should build, learn, find challenges, overcome them. JavaScript is quite powerful because it has a monopoly on the browser, so there's a vibrant community, resources around it, and a really good ecosystem. I would, as soon as possibly though, learn a superset of TypeScript, which is JavaScript with types more or less, and learn that as it is the industry standard. It's once you go there, you won't come back because it's very ergonomic. I mean, some people don't like it, but that's a topic for the drama of the tech industry. And generally, I advise you to, once you get a bit comfortable, always try to learn the best way to do stuff. And TypeScript is the best way to write JavaScript, let's say. Even more concretely, once you get comfortable with JavaScript, it's important to recognize the world as front-end and back-end. Lots of people focus on only one of these sides or even one of these tools, such as React, but I would say beware of that. You will have a really good benefit if you have a holistic understanding on how the whole stack works. One thing you will encounter in engineering is that we often need to create abstractions. However, abstractions come with a high cost of being leaky and introducing complexity. Splitting your world into front end and back end and only focusing on one means there will be a lot of abstraction, and yeah, you lack that holistic understanding. So concretely, I'd strongly recommend to learn React, as it's become a UI paradigm and an industry standard. There's other tools, but you can learn them later. And for the backend, I would learn Node.js with TypeScript. Node.js is basically JavaScript in the server, and use a simple tool like Express to have your server. Later, you can go down the rabbit hole of learning stuff like GraphQL and other stuff, but I would go with the mainstream industry standard first before you branch out into more experimental and esoteric directions. Once you have your backend up and running, the question becomes after the database. MongoDB, NoSQL is basically super easy to get started with because you can simply dump your already existing data structures, your JavaScript JSONs, into it and just simply save them. However, you will shoot yourself in the foot in the long run, as you still have to learn some complexities. But generally speaking, I'm not the biggest fan of NoSQL, and generally it's regarded as more of a niche tool for certain applications. Instead, I would highly recommend learning SQL, MySQL, or I would recommend to learn PostgreSQL. It's slightly more difficult to get started with, but once you get the hang of it, it's fantastic to get going in it, and you'll learn the industry standard again. These topics and tools alone are very deep. However, if you get at the end of the road or more advanced, you can think about learning the different ways of actually deploying applications that there are, such as Kubernetes, Docker, and continuous integration and delivery with, for example, GitHub Actions. Currently, I'm learning about microservices and event-driven architecture right now at work. So the more you learn of the stuff, the more interesting it becomes. Speaking of front-end and back-end, there is basically a spectrum here, and that's the last point I want to touch on. You can think of deep diving in the front end or the back end, and I would say this can express itself into the esoteric shenanigans of CSS and SQL. Both of them can be esoteric, people specialize in them. What makes them tricky to learn is that the aforementioned feedback loop is not as solid in them. This means, for example, in CSS, there's a history on how CSS developed. Most recently, we got Flexbox and Grid, which is nice, but there are other systems and there's a lot of edge cases that you will encounter over time and that you will also forget about and then stumble upon again once you have to work with it again. Because it is visual, it is hard to debug things, and because, these edge cases, but also because there might be a component tree where in the middle or downstairs, something is visually not working, has the correct attributes, but is affected by a parent component or even child component. So this makes it tricky to work with CSS. You need to have a really good understanding on how it works and how its rules work and where they apply. On the other end of the spectrum, you have SQL, which I always was a little bit intimidated by, but I've learned much more about it in the last couple of months, and it's actually quite plain and simple to get at least started with it. However, once you get beyond the error being an anonymous syntax error message, and you fix those, you get into more complicated and complex queries where you have many subqueries that relate to each other. And here the tricky part is once you have real data and you want to ask a question and learn about this data, it is tricky to verify whether or not your queries actually work, and because you just get some numbers and you're not sure if you maybe made a error in your calculations. It's a bit like in statistics, you make some calculations, you get some numbers, you're not really sure if those numbers are correct, if you made a conceptual error. And in SQL, one way to combat this would be to have a test database that you fill up with really simple data and then make your calculations based on this, and you can verify that they actually work. But yeah, it's basically tricky because the aforementioned iterative feedback loop doesn't work as well here. So I hope you found this video interesting, and I hope you have a really good day. Bye.